first things as usual, I thought we could go around and do a short introduction of yourself and what you do at Prospector. So Jon, you're my closest over here, so go ahead and you can start.
Okay, I'll take it. Oh, it's the reverse. Hello.
Oh, yeah.
I'm Jon. I'm Jon Gabu. I'm one of the co-founders with Emily, and the COO and CTO of Prospector. So here overseeing all of our product development and operations. Alessandra?
All right. So I'm Alessandra Morante. I am from Peru. I'm the head of data, so I supervise every data that gets into our database. Tetyana?
Hi, I'm Tetyana, and I'm the head of data science here. So I think that's a meeting very relevant to me because we will be showing you some AI cool stuff.
And then I think I'm last. I'm Emily. I'm the other co-founder and CEO of Prospector. And then back to you, Jess.
Yeah, awesome. So I'm just responding to everybody in the comments here. We've got lots of people joining from all over the world. Hello, I'm Jess. I'm the head of new media. And as Tetyana said, we have a great discussion here for you all today surrounding kind of like artificial intelligence and technology in the mining industry. So before we got started, I thought it might be fun to pull up a poll. I don't know if you have all seen this like Mentimeter poll before, but it's a very interactive poll. And just kind of get your guys' inputs on artificial intelligence. And so I thought it might be kind of a cool opportunity to start off this conversation with us, each person saying a pro or opportunity or a con or risk of artificial intelligence and kind of where we see that going. So we'll just go in the same order we did. Jon, you first.
I said I'm excited about it. So, yeah, I think there's lots of opportunities, and I think there's some very specific examples that Tetyana's going to go through today that kind of like shows what this all can do, right? And I think it's but with anything, there's risk to any tool, right? And it's just important that we all learn how to use the tool in the best way possible. We all had to learn how to use a calculator. We all had to learn to use Google. Let's learn how to use AI properly and ethically.
I don't know, those calculators still have some ethical issues with them.
Alessandra, what about you? I know you had some opportunities and risks that you had talked about for AI.
Yes, I know. I kind of understand the perspective I'm from the perspective of the people that is not from the engineering side, not from a data scientist, and wants to get into artificial intelligence. So for me, it was just a black box. So I see why some people maybe have a few concerns about artificial intelligence. But we heard in the recent years, there is so many usage of artificial intelligence in every department of the mining industry. We have heard a lot of using of artificial intelligence in exploration and mining operations. However, and in the middle usage, let's say environmental and health and safety. But we can use it even in finance. We can use it in investment. We can use it in supply chain. It can be extended extended to the whole company. And that's why one is one of the benefits or the opportunities that I see in artificial intelligence is optimization and taking decision fast with the data available and updating frequently. But however, as I was saying, in terms of risk, we know that for people that is not directly involved in artificial intelligence, it's just a black box. For example, I was talking with a US consultant on Friday, and he was telling me that I understand, I know that there are a lot of benefits from artificial intelligence, but how can I sell the use of artificial intelligence to my clients when most of them does not comprehend what is in it? What does it imply using artificial intelligence? And as I told him something that was really fun, because I told him, for me, it's just econometric with asteroids, because it's a way to use the more diverse data from different sources, but applying things that we have seen on econometrics or statistics. So that's one of the risks is transparency. We need, secondly, we need also high quality data, because if we are going to train the model, we need to make sure that everything is of the highest quality and unbiased. Also, as we use artificial intelligence, a way to putting our data, let's say, as sort of online. So we have a still risk of cyber attacks. So there are some risks, but I think that every company may be able to address those risks and give room for all those opportunities that I think that Tetyana and Jon may be able to explain in more detail. But there are tons of opportunities, but we still have some risks, and most of them I think that come from the people that don't fully understand how does it work.
Great insights. Thank you, Alessandra. And then Emily, I'm going to hand it over to you before we go to Tetyana, because I know Tetyana's got a whole brain full of this stuff. So,
yeah, I think for me, the huge benefit of AI and the different tools that make up AI is that you get from data to decisions faster, much like Alessandra said, right? And it helps bring structure to unstructured data. I think the risk that I see is not so much the risk of the technology itself, but I worry sometimes that people don't understand garbage in is garbage out. So if you put data that's inaccurate or incomplete into any kind of technology, the product you get out of that is also going to be inaccurate and incomplete. So you could have a great AI model, great tools, but if the data itself isn't super solid, then people will think, oh, it's the technology that's not working, right? The AI isn't working. And that's not the case. Sometimes it's the data set isn't complete and accurate and up to date. So that's what I worry about, is AI maybe getting a bad rap because of some of the platforms that have come out super early, but they were pulling in, a not so complete or accurate data set. So people think the technology itself has those issues.
for sure, great insights. All right, Tetyana, opportunities and risks, pros and cons. What do you think?
Okay, well, to me, artificial intelligence is basically the extension of human civilization. So it's a very logical future, and we cannot escape it, because we might have gotten used to our life as we have it, but let's face it, there are so many problems, and we are finally getting to the point when we can start addressing some of them, and that is pretty much everywhere. If we talk about mining, we don't want to send humans to somewhere where humans shouldn't go. Think about space, right? How long are we going to send real, actual humans to potentially face very adverse conditions in space? We don't really want that until we make it comfortable, but we already want to mine something in space. So we need to send robots that can make decisions, that can adjust to the situation and handle what is happening towards them. So we cannot give them all the answers, because we do not have answers, and that's exactly what artificial intelligence is. Think about areas like health. Again, we cannot, we thought we can do so many things, we can fix so many diseases, but actually we do not understand. There is too much data. There is 30 trillion cells in a human body, and what these 30 trillion cells are doing, we have very few ideas. If you look at clinical trials, they are most of the time incomplete. You cannot get even a full sample of individuals who can go through the trial. So we need to do something else. We need to create artificial parts of the body that can be used for testing. We need robots to process the data. We need artificial intelligence to connect the dots and give us some idea of what is happening, because we just cannot process it. A human brain is a bit too slow to load all of this information and then try to categorize it. And then we all also want to go and live in somewhere, right, and forget about it. So we need robots that can do that better. So to me, that is the opportunity is so blaringly obvious that there is no way we can go back or ban AI in any way. But of course, there comes a lot of risks, a lot of dangers. So if someone good can use AI for the good thing, someone bad can use AI for the bad thing, right? It can. We have more risks now. We can face a virus that would infect all of the AI over the planet, and whatever it can do, it might be just, somebody's silly joke that would collapse the whole system, and we are so reliant on it. And we have to start I say AI police. So we need to create programs, antiviruses, so whatever special bots that would go and check what AI models are doing, how they might be harmful, how they might be changed by malicious individuals, or they can get sick on its own, right? Because now we are talking about AI, there can be some unintended consequence of the design that manifests itself in a rare case, but that rare case is very tragic for the human civilization in some way. So a lot of problems to solve, definitely not going back, going forward and trying to learn how to control this new power that we have as humans, trying to know how to make it better, how to not waste it as well. Because if you think about AI, it's a very costly thing. It's kind of hidden from us, right? We do not see all the electricity that goes into training the GPUs. We do not feel it because we switch on the light at home, it works. It means that there is plenty of electricity. But in reality, training a GPU model, such as a large language model, is very costly from the power point of view as well. And we need to think how we optimize that problem as well, because we don't want to endlessly generate electricity, especially if it is from not so clean sources. And pretty much all that we do right now is not too clean. Even if we talk about wind power or solar power, there is a lot of unintended consequences. So we need to think about efficiencies and how we move forward. And final point, we need also to democratize AI so that it is available to every human. It's not something, OpenAI, very, very obvious name. It is OpenAI that is close to everyone. And we cannot use their models unless we pay, which means that it is closed to large percentage of population who potentially do not have a credit card, right? Why cannot they use it? Everyone should be able to use it. So that's my take on AI.
Those are great thoughts and insights, Tetyana. Thank you so much. My thing with AI is a lot of people need to remember that it's a tool, right? It's something that you can use to assist your everyday life. Like, I see a lot of people leaning on it for a lot more than they should. And as Emily said, garbage in, garbage out. So definitely use caution with that. But I think I'm so excited to see where the future of it goes. And so I'd love to hand it over, Tetyana, to you and Jon to talk about AI in the mining industry and kind of what you guys are working on and some explanations on its uses. And I'm excited to learn from you both.
Jon, you please start and explain the context.
Yeah. So I think I think it's good to start with maybe how we use AI today and how we're planning to use AI in the future. So at Prospector, our main thing that we do, right? We have roughly, I think, 2.5 million documents, right, that we keep from public exchanges, have to go through. We take those documents and we extract a lot of information out of them. What we use AI for, and one of the early things we used AI for, was to essentially classify them. How do you figure out what's a drill result? How do you figure out what's a technical report? How do you figure out what's a quarterly update? This is not straightforward coming from the exchanges. And then how do you, from there, move to something that's kind of like a human-centered loop? So we've over time tried to predict, okay, well, if this is a technical report, this AI model is going to predict with this confidence level that it's about this mine, or it's about this metal, or it's about this resource estimate, or it's about, this geological model. We try to build subsequent models that do this stuff. And up until, I would say, even this spring, right? So I think that, if you look at some of the models that are out there, and this is what Tatyana is going to kind of show what's in the realm of the possible now. The large language models could kind of extract those things, and you had to really curate them, make sure what's going on. But now they've sort of gotten to the point where you can actually feed a lot of text in, and you can get some really, really detailed data extraction out with little effort. This is coming with GPT-4 that was released by OpenAI. I guess it would have been like 4 months ago now. And Claude AI, which comes from Anthropic, was just released a couple of weeks ago. It's truly impressive, right? We've been looking at this as ways to extract text in tables at scale from Joel results, from technical reports, from quarterly results. And I think we're really excited. We're starting to look at the ways in which we build that in. Again, we don't just straight extract these things. We put it through a human loop, but the amount of time it saves, right? So if it takes an analyst to extract, let's say the production metrics of Ignico, let's say it would take 45 minutes, right? Normal time. If we can use the AI to take that down to 15 minutes to 10 minutes, that's huge for us, right? And that's just more data, more things that we can get that's out there. And that's really where our focus is in the way that we look to use AI as a company, right? It's never about automating. We do want to create the nice, fun to use chatbot at some point. But for us, it's really about, how do we do this at scale, and how do we accomplish, what it may take 10 or 20 people to do with maybe 4 to 5 people, because we're using AI as that co-pilot to help us out. And with Tatyana, I know you have some stuff you want to show that kind of gets into this, so I'll hand it over to you.
Yeah, I will still ask you to help with the, explaining some of the things.
Sure. And so just reminded me, Tatyana, is this the Joel result? This is the production one first, or the technical report one?
So drill results will be second, because and that's that would actually fit quite well with why AI is not solution for everything, and we still have to be careful. Yeah.
So.
Oh,
do you want to go?
Yeah. So I'm gonna demonstrate extracting production sales, cash costs, AISC, all-in costs, average realized price for each metal and mine discussed in text. And the text, so this would be a little bit technical, but I think it is required to go through some of the things that we are doing to make it more understandable. So what we have here is the query that goes to our database and collects the text from documents that we have. And I have just executed this query, and I received 2,306 results. So this is a lot of documents. If you imagine an analyst works on a document like this, let's say around 100 minutes, which is an hour and a half plus a little bit, that would take you something, what is 230,000 minutes, which is quite a long time. What we can do with ChatGPT in this case, we can take these results one by one, put them in a loop, and get our production numbers that we need. So what I'm going to take now, I'll take row 1. So we generate the context, and the context here is actually, I'm going to run this cell again. So this is the text that we get from our documents. This is not one page. This is a few pages from different from a section or several sections, and you can see that just to read this, it would take an analyst maybe like 5 minutes, maybe more, depending on how used they are to this text. What we do next, we construct a prompt, which is basically we give this prompt to ChatGPT and say tabulate the production sales and so on for each mine discussed in this text and include units of measure. So we create this one. And the next thing is I do call this, and it will take a while. And if you saw the previous message that was the result of this call, it was actually saying that you cannot process more than certain number of tokens per minute, and please wait another minute. So this comes to the point of resource utilization and also democratization of AI. So if you can pay, you can get once a minute you can get to process a certain length of text, but at the same time it takes a lot of electricity that you are not really aware of, but it is there. So this is the result in a not a very nice looking way. And then we can process it further. I think it didn't fit in the table too well. Jon, can you comment on this one, or should I?
Yeah. So what we've done. So I believe this is Perseus mining. The documents from, because I think that's what it is. And so what this is showing is the production, the all-in sustaining cost or all-in site cost, what their forecast is for production site costs, and how that compares. So it extracted from the document. So again, when we have analysts going to capture these metrics and tabulate it, put in our database so that someone else can query it on a more global level, this is sort of one of the first steps that goes into that. And what's important about sort of the advancements in the last 6 months or so is that we could have given this task, and Tetyana and I went through a bunch of experiments using the deprecated models, so GPT-3 versus the current GPT-4, to do this, where it does put a response. The response looks credible, but the problem is it seems that GPT-3 hallucinates. And I don't know if folks are familiar with the term hallucination, but this is when the AI models make things up. Because you remember, when we're using generative AI, you essentially have a very fancy autocomplete, right? So it's using text and things to reconstruct what it thinks it wants you to say. And so putting these prompts and going through the text and providing that context is a way to kind of control that. But if the models aren't some of the more sophisticated ones, it'll actually make up numbers. So if we were to import into our database this directly, we want to make sure that this is the correct number. We don't want to just take it at face value. So what our analysts would do with this, right, is they would look at the result, they would look at the pages that were referenced, and they would then confirm this before submitting. Right, it does save a lot of time. And what's truly impressive, I think, is this is a relatively Perseus has got 3 producing mines. We did this for Agnico's quarterly filing recently, and so Agnico has probably over a dozen different operating mines, and we asked it the same prompt, which was give us the sales, give us the production, give us the cash costs, give us the all-in sustaining costs, break it out by co-product and byproduct, tabulate it, and give it back to us. Then give us the citation. Models were able to do that. And then we went back and checked it, right? And sales were right, production was right, cash cost was right. Interesting thing, Agnico does not report all-in sustaining costs per ounce explicitly for each of its mines. So we went back to the model and it gave us the justification. And what was truly impressive, I think, about it, and again, these are models that have come out just the past couple of months, is it said, well, I found the section that explains what all-in sustaining cost is, and explained that X, Y, and Z contribute to the all-in sustaining cost. So what I did is I went and found those top-line dollar amounts for each mine within the report. I added them together, divided them by the sales ounces, and added them to the cash cost. And that's how I calculated it. So for us, this is an really, really kind of pivotal moment because, not only was it able to kind of regurgitate the text and put it in a tabular table, but it was able to understand the logic of how to calculate things. And I think that's what's really exciting about the future, is that not only can we train the models to extract key metrics from within the documents, but we can get it to derive metrics that may not be explicitly stated, so you can create a more full picture of the data surrounding a company or a particular mine.
Mm-hmm. Should I try the drilling results for
Yeah.
comparison?
Sure.
Yeah. So the thing with drilling results, the text from which we want to extract is a little bit longer. So I had to find a shorter one. So again, the process is the same. We have a query. This is coming from our database. And then we get the data. Let me calculate how many results we had there. 9,000. So 9,000 documents that we need to get drilling results from, which is not an easy task, as you can imagine. And I'm going to use one of the rows in the results in this 9,000. And let's see. So we have a text that is 166,000 characters. And it looks, let's hope that it does get processed. So that's how it looks like. There is, so that is probably some tabular form of data in any case, but it's not really put correctly in text. So this is what we are dealing with. Sorry, very long. Imagine how long it would take for an analyst to read and estimate what's happening. So then the prompt here would be tabulate the LOMP to include discount rate, IRR, NPV taxes, metal prices, stage production of metal, recovery rates, mined ore, processing, mining grade, capex, opex, mine life, royalties, and include units of measure. Okay, I wouldn't be able to do that, even if you give me a week. Let's see how our GPD, okay, that is too long.
And this is where, you know, before we put stuff out into production, there's a lot of effort that's going to go into actually isolating these kind of prompts. So if you can imagine, Tetyana's doing a prompt that probably, when we end up implementing it, will be 6 or 7 different prompts that'll focus on different bits of information that we can isolate within the document. But because we're looking at, you know, the economic section, we're looking at the operating net capex costs, we're looking at, you know, a lot of other aspects of the actual report, right? You have to include a lot more text.
Yeah, so I had to drop it back to 13,000 characters. It looks like it is thinking right now. And while it is thinking, basically what is happening at the back of the model has to deal, you know, the model is still a mathematical model at the back, and it can usually deal with the blocks of text of a certain length. And the text is usually padded to always be the same. Those blocks of text are usually not super long, like maybe 250 words. So when you give it 100,000 words, it basically has to break it in this text and put all of this overlapping pieces of text together and then make inference based on these pieces and then reconstruct them. So not a very easy thing to do, if you can imagine doing it in your brain. So let's see what it's found here. So not as productive, but it found the recovery rate.
And I think what's interesting about this is, you know, OpenAI has a much more restrictive token policy than, say, Anthropic, right? So as we've been sort of testing these between the two models, and this is the OpenAI one, the Anthropic one actually allows for, like, you know, 3 or 4 times as many characters, which improves the functionality, right? Because we want to give the model the context of that document as much as possible, right? So it can understand and look for all this information. But still, if you think about it, it's relatively impressive that it looks like maybe the early part of the document was talking about it's an exploration stage asset, and it's got a recovery rate assumption in there. So maybe it's and not even, and maybe it's not, there's not been a full life of mine plan. It could be just a resource estimate, right? So
yeah, so it's not necessarily that the model was not able to do that. It can be just because I did cut a large portion. So I basically took 10% of the text. So this is because it's a document, and in certain sections of the document, certain information gets discussed. So it's pretty much, I gave it like first page, and not everyone would discuss everything on the first page. It's that's our human way of writing stuff also gets in the way.
Those are great great point. I'm just like blown away by this side of things. So thanks, Tetyana and Jon, for showing that. That's a lot of data. And I thought really quickly before we head over to the more like data side of things, you Jon, you briefly like mentioned like a ChatGPT bot, but what other like kinds of things do we see in the future of mining industry for AI in mining? You know, besides like a chat bot, you know, we think of AI, well, I think of AI and I think image generation and stuff like that. But what other opportunities are you two thinking we might see? Like, where does this go?
I mean, obviously robotics is an interesting one. I think the Google folks just had a really interesting update last week, where so to date, a lot of robotics has been about programming like individual things that you want the robot to do, right? And you put constraints on that, you know, like this is how you move your leg and do those things. What's interesting is Google has been playing around with using the large language models that they have and incorporating how you program things using those large language models into the broader context, right? So instead of, say, programming a specific action, they've been working on ways to use like text to speech and coupling that with a large language model to interpret what that means and then have that programmatically tell the robot what to do. So what does that mean? There's a podcast called Hard Fork where by the New York Times that did a visit to the Google lab, and they were showing that like how to, I mean, the robot didn't do a great job of it, but the robot was able to, like you told it, get me a Coke. It was able to visually scan and identify a Coke in the room, walk across the room, pick up the Coke. It spilled the Coke and brought it back to the person. But what's interesting about that, so if you just kind of step back and think about, well, what are the implications of that? Well, to me, that means that large language models in themselves are sort of a force multiplier about what we could have autonomous things do at our command, right? If you think about like work inside the mine shaft, or like, I think there's a lot of great opportunities there that are maybe make it more accessible, right, for more people to do, and to not be so heavily reliant on being a software engineer or an engineer to do something. Maybe that you can imagine like co-pilot type systems that make it easier to have these things being assistants to things. I think that's like super, super interesting. And I think the other part is just if you think about pit design, right? Like imagine just being able to send a prompt and get like 6 or 7 pit designs based on a bunch of different parameters you give in a geological space and a bunch of assay results. Like that's, to me, interesting, right? Like that, there's a lot of analysis that could be done more effective, maybe more cost savings, right? I think there's a lot of opportunity for those type of things in the future. So I'll let Tetyana give her perspective.
I don't really have much to add. I think that's my view of mining is a little bit more generic. So robotics and better designs, potentially better ability to find minerals that we are looking for. Wait, I just thought about something. I think with the power of AI and ability to program things better, to not only better but faster, right? So I am a software engineer for more than 20 years, and I know how a simple problem, when you decompose it, it becomes kind of much bigger. And I think that kind of takes a lot of time of the software engineers to decompose the problem and then to design those small components. And what I see happening with this large language models is we do not have to do those small components anymore. We can get something done for us like in seconds, which makes our life is so much easier. And with this ability, what we can do much better is we can create better models of the environment and understand better how we can damage or not damage the environment by starting mining in a certain place. Because most of the time when humanity fails, it's not that we are doing intentionally something that we don't want to do, or something that we know is going to be very harmful. It's mostly the unknown unknowns. We do not even know that we should be considering something like this. And we do not know it because we don't have enough data. We cannot put things together. So, and we do not have time, right? If we had unlimited time, we could have thought it out properly, but we cannot because we need to live, and our life is actually very short, and working life is probably even shorter. So we have to proceed with very partial knowledge. So if AI can help us with this, we can do much more, much better.
Great. So how long until the robots take over?
I'm not of the mind that I don't know that the robots do take over. And I think this is I think a lot of people, I think we anthropomorphize this AI itself. And I think a better way to think about it, and I had this epiphany. If you ever watched The Expanse, the first time I watched it, I remember telling my wife, was like, it's set 300 years in the future. I'm like, one of the things that kind of bothers me is there's not more AI. There's not a lot of AI in the show, right? There's not like artificial robots going around doing things for people. But I started reflecting on that, thinking about the way that we use AI now, right? Which is, there's a lot of like voice command stuff, a lot of autocomplete things. There's some analysis that we can have it do. But the way it's reflected in the show, right, is they're in space, is usually it's, like the chief engineer on the spaceship is like, okay, run me 5 different models about how we could do our flight path from, Mars to, Titan, right? And how that would look, and optimize for fuel and do all these things. That's AI, right? But we don't think of that as AI. And I think maybe we'll get to artificial general intelligence, right? The idea that I think what we all conceptualize as AI, the scary thing where Terminator takes over and enslaves us. But I guess I'm feeling more optimistic that maybe it's like there's little bits of AI that kind of assist all kinds of little things that we do, where we sort of maintain our control, but it's something that just augments our ability to do things in the same way that Google search or a calculator get used to enable what we do.
That's great. I don't know about you, but I still say please and thank you to ChatGPT just in case. So just to kind of finalize and wrap things up, AI really starts and ends with data, right? So Alessandra, I just wanted to throw it over to you for final thoughts on data and its importance in getting clean data for this AI and how you're doing that with your team.
All right. So as I was saying at the beginning, is just I believe in the power of artificial intelligence and all the potential it has for all the departments in the mining industry. Talking specifically about what we do in Prospector, we are mostly focused on providing data for decision makers. So we want to make sure that everything that our clients receive is high quality data and highly understandable and comparable. So for that matter, we have a team of geologists and mining engineers working with using the artificial intelligence just to simplify their job. We are not fully automatization or doing this automatization of all the whole process from the data extraction to the classification to the data that is provided to our customers, because we want to make sure that the data is interpreting correctly. So everything that is delivered is being supervised by a team of mining geologists and engineers. So And that is also useful in two other phases. First, when we develop our models, we use the input from mining engineers and geologists because they are the ones that know what type of data we need to create a tool or to be presented to the decision makers or the people working in the related to the mining industry. So, and also we want to make sure that the data is comparable. For people that working in finance or investment, we know how it's important to compare one asset to another one, especially if you want to do an investment in one mineral or region. So we standardize the data and we make all the conversions, but we need to make sure that everything is working smoothly. So we have a team, the same team of geologists and analysts verifying that the validation and all the conversions are correct and accordingly to the behavior of the mineral or just the behavior of the mineral, which is different, or a type of mine. So I would say that we need artificial intelligence. It makes definitely reduce the amount of time that the mining engineer or geologist spent looking at or reading filings, because as we know, it can simplify or change from 45 minutes to 15 minutes their job, but we still need these people working behind it and supporting and verifying, making all the validations of all the data that gets to our customers.
That's great. Any follow up on that, Jon and Tetyana?
100% agree.
Great. That's always a good thing.
Human in loop AI.
That's perfect. Well, cool. I think I don't see any questions. So I just want to take a quick second and thank everyone for joining us live. And for those of you that are going to be watching this in the future, we'll have a video replay up here on LinkedIn, but also on our YouTube and social media channels as well. So be sure to follow along and check those out. Team, thank you so much for all of these great insights. And I look forward to seeing you all in our next monthly mining roundup. Bye, everybody.